Hey. I have to drink because already people have already joined. Out of 350 points, that will be allowed. Maybe 232. Yeah, I'm on my favorite pastry.
They just fixed the engine now. So much.
Okay.
Now we
So you do from? Why are you very good money? You're still. How do you know? I will be finished home. Bagadam. Wait. Till my glass close. Hey. This one from back then. I've been here since. I want to buy that. It's not even like this. Yeah, and the dog no different. I think she's dying. Now I'm telling one. Nathaniel, what happened to you? Nathaniel, what happened to you?
Zoom.
If you know the daddy that you have, then it's going to go.
Yes, sir. But the class starts at 9.
I just see my dad, she was like,
It was always 9.
Don't worry.
You put it to my head. I just look at the time now. The time is there. You just don't shut up. Why? What I do? Straight up to me, shut up for no reason.
Drop my back inside the class. Hey, see you. Your mate have now finished. Yeah, it has given me what happened. Jump. I meant to get to do. What do you want me to say? How do you enter, uncle? Let's get it. Open the gate. That time you not come down nothing. You never know the way to go. You don't know the way.
I go now.
No, really, no.
Forever in your presence, I will chase everything that's true for you.
Wow.
I don't know why. Do you see me? Because I see you. You always blind. Chances are you have succeeded.
No, you're not. What she does? Very it.
You succeed for me, but you wouldn't poison me.
Coming. Collecting.
When you left, you know, one of the things that you did that after I send you message so I'll make sure you answer. You know what I'm saying? What 4 times? You know, not the everything. That was the exact one that she had for me. That's what I was glad. I have just about enough. Right now, all I want more than any other thing in this world for you two to get the hell out of my father's house. Get out! I mean, get out of the house! There's nothing that is in this house. No. Out. Please, just listen. Hey, now! Listen now. They wanted to tag you guys,
Like, are you telling me you don't know those guys? Like, you don't know when did it to me?
On file. You know that's fake blood. They are somewhere. Fake blood.
It's not me, man. You know the most what I put for yeah. You have used my body. Did you use this without me? Did you? Okay. What's the percentage of the phone? Can I remove it or I should say plug it in? Maybe yeah.
Not yet.
Wow.
Taking go back.
Oh, good morning, class. So,
Good morning, ma. Good morning, ma.
Good morning, ma.
I hope we are good, right?
Yes, ma. Yes, ma.
Yes, ma.
I hope we have our writing materials.
Yes, ma.
Yes, ma.
Okay,
Yes,
let's
ma.
wait like maybe 5 minutes more so that to justify the time for the class. The class is meant to be by 9, right?
Okay, ma.
Yeah, let me just for 5 minutes. Can start. Thank you very much for tuning in on time. So we can optimize our time today by the grace of God. Let's start taking attendance. I realized that the attendance that was shared via your course reps yesterday was more than the attendance that were visible online. And if there's anything I appreciate in life, is sincerity and integrity. Being a course rep,
on YouTube.
yes, now that's what I'm saying. I calculated it now. So being a course rep, I want you to maintain integrity. If your friend is not available, don't say because you're my friend, I'm adding your name. Please, it will help you to go a long way in life. Just be a straightforward person. Like don't say no sentiments affect your judgment. I will appreciate that very well. And I want you also to encourage yourselves as much as possible to be available in class. Because the essence of this attendance is just to motivate you to be available. You cannot get it well when you get it from the third party. Please, I want to encourage in everything you're doing, in every of your classes as a student, make sure you aim at being available in class. So being available in class is one thing. Then you can also end up having a group discussion group where you guys will gather and rub minds. I also I want to use this period to talk to you before we start the class officially. So I want you to know that you are here to make an impact. I don't care to know the background you're coming from. Your parents are made or your parents are not made, but what matters is you, your own future. Your parents' wealth has nothing to do with you, because if you don't know how to manage wealth, even if your parents happen to give you billions of naira, it just takes a matter of months or years for it to go. So that's why you have to train yourself for yourself and also for your future. So being a student, make sure study is your priority. Don't follow your friends because you don't know the assimilation capacity of your friend. Your friend might be such a person that as soon as she spends 30 minutes, she can absorb what somebody cannot absorb in 3 hours. And also try to make sure you understand your time you absorb more in reading. Your time might be early in the morning, your time might be in the afternoon, or in just follow your own time. Don't because your friend is going to library by 2, you're going to library because of your friend. And you realize when you get there, you will not achieve anything. Your time might be read, go for classes in the day, sleep and wake up at night to read. Discover who you are. So it's going to help you. Don't follow. When you follow people, you become a photocopy. Just be yourself. Discover yourself. The essence of being in school is just for self-discovery. Discover your strength, discover your weakness, and harness your strengths. Optimize your strengths. Now, discover your passion. Your passion and profession is going to make you a great person in future. Don't be the kind of person that just want to read to pass without having something. Discover who you are. Discover your talents. No, God created us with talents. So you have a talent. So discover that and optimize it. If your friend cannot change you for good, change your friends, please. If you're better than your friends, you can only depreciate. Your friends can either add to you, subtract from you, or divide from you. So you must follow people that add to you. Anybody that subtracts from you, you don't make them to be your close friend because they're going to make you to be depreciating each passing day. You'll be there to help them, not to imitate them. Follow people that will motivate you and that will challenge you to become a better version of yourself. Please, the most distraction you have as a student, including myself talking, is your cell phone. Some of us waste our time watching people that are celebrities, that have made name. Why we are not even working for ourselves to be a celebrity tomorrow? So make sure that whenever you're online for something that will benefit you. Don't go and add to people's wealth while you're getting poor each passing day. YouTube should be an avenue where you go and listen to lectures and make yourself better. Or there's something you're looking for that has to do with your passion you want to improve on. Please, this is the time you invest in your life. Invest the time. Let this time you're spending in university or play, let it worth it, let it count. Some people that are in final years now, they are regretting because they didn't have time to optimize their opportunities when they were in 100 level like you. And some of them are here now carrying this course over because they were feeling that, we'll deal with it. And maybe at the 11th hour, they start reading. And when they enter exam hall, everything bubbled up. Chemistry is not a course that you'll be reading 11th hour. It's a course you're going to read one at a time, just like mathematics. So by now, everybody here is supposed to have their timetable. And discipline yourself to follow your timetable. Don't mortgage your destiny on the bed of sleep, on the bed of comfort. There's a saying that nothing grows in comfort zone. So this is a time to discomfort yourself. This is a time for you to start so that tomorrow you have abundance to eat. This is a time for you to have a sleepless night, burning midnight candle so that tomorrow you're going to have enough rest. Please, please, and please optimize this time. Let it count. Don't be distracted. Anybody that comes to you and is a distraction to you, please separate yourself from distraction in name of your friends, in name of gadgets and stuff like that. And I know that if you follow what I've just said, discovering your reading time, discovering the best friend that can motivate you, separating yourself from distraction, making sure you're always available in class before time, and always have time to revise anything that has been taught to you each day. Don't carry it over. At the end, you're going to come to my office and thank me because you're going to make A, not just in this course, but in all your courses as a student. And I'm going to celebrate those of you that are going to be the best student by virtue of this instruction. I want to tell you something again, that I don't care to know your background. I don't care to know whether you're intelligent or you're not a smart person. That's something I got to know, but I got to know it when I was in university as a student. I got to know that so many people that are like genius, as in A students, are not really naturally brainy, but they add extra time to their time in study. They study more, so do more, go extra mile to get that desired grade. It doesn't come by sleeping and waking up. Even somebody, I know a student that was very intelligent in year 1, he was doing very well, but along the line, he felt that he's good. He became distracted. As we are talking now, this person is having extra year. So it doesn't matter being intelligent. What matters is dedication. Let me use this scripture to conclude. The Bible said, see that a man diligent in his business, he will stand before kings. He will not stand before men. It did not say, think that a man that is intelligent or born a genius. Diligent. Diligent is what you need. Be diligent in your studies. So at the end of your studentship, you'll be celebrated. So that is all for now. So let's go into the class. Good morning once again. Okay. In the last class, we were talking about bonding. We talked about what a chemical bond is. And I told us that bonding is just like a relationship or a connection, a link, association between two or more atoms. That's why they say it takes two to tango. Either they are donating or they are sharing electrons in this bonding. Then we talked about types of bonding. We say we have ionic bonding, we have covalent bonding, and we have metallic bonding. And also in today's class, I added another bonding, which is because somebody was brought that to my notice. I said, okay, let me also let you guys know that we have coordinates dative bonding. Coordinates or dative bonding. So that's another kind of bonding. This coordinates covalent bonding is also called dative bonding or dipolar bonding. So that's another kind of bonding. So maybe a question can come and say, which of the following is not a type of bonding? Which of the following is not a type of bonding? You know that we have covalent bonding, we have ionic bonding, we have metallic bonding, we have dative bonding. Dative bonding is the same thing as coordinate covalent bonding. Okay, it's the same thing as dipolar bonding. So in today's class, we're going to continue from where we stopped yesterday. For people that were not available in class, okay, let me just start with that covalent bonding. Now, covalent bonding, like I said yesterday, I was talking about covalent bonding being a kind of bonding that there is sharing. Covalent bonding can also be a kind of bonding in which electron pairs are shared between atoms with similar or identical electronegativity. If you look at in the previous class, I was using sharing of similar, but it cannot only be in similar. They can only share with atoms that have identical or similar electronegativity. So it might not be only chlorine atom molecule, hydrogen molecule, oxygen molecule. In methane, for example, the bonding between carbon and hydrogen in methane is covalent bonding. Why? Because carbon and hydrogen, they have similar electronegativity. So when we're going to talk about hybridization, you can understand, because in carbon, we have 1s2, 2s2, and 2p2. Okay? Now, hydrogen is going to come and bond with carbon. Look at the structure that we have. You can see in that methane. Let me expand it a little. In that methane, carbon has 4. That's why carbon is bonding with 4 bonding sites, because it has 4 electrons at the atomos shell. So it needs another 4 hydrogen to complete its atomos shell. So that is why the bonding of hydrogen and carbon in alkanes or hydrocarbons is simply covalent bonding, because they have similar electronegativity. So, but when there are differences in electronegativity, we go for ionic bonding. But when there are similar in electronegativity, covalent bonding can occur. So covalent bonding can come in a similar atoms and atoms that are not similar. They are not similar. They are the atoms that are different but have similar or identical electronegativity. Okay, so that's one thing that you should know about. So if the question is like, which of the following compounds are formed by covalent bonding? If I put something like sodium chloride, you know that it cannot be covalent because sodium and chlorine, they have different in electronegativity. And if I put something like alkanes, any form of the alkanes, you know they're going by a covalent bonding. If I put something like oxygen molecule, it's covalent bonding. So for us to understand the difference between ionic and covalent. A covalent does not only entail molecules, they can also occur in a compound that have similar or identical electronegativity. I hope that is taken before we continue. Any question on this? No. Ionic is heterolytic, while covalent is homolytic. Yes. So let's go to the next one. Because somebody was talking about what of dative bonding. Now, coordinate bond, which is also called dative bond or covalent or dipolar bond, like I said, or coordinate covalent bond, they are the same name. A question can come, so which of the following is the odd in the group? So we can just talk about, so understand that our coordinate bonding is the same thing as dative bonding, it's the same thing as coordinate covalent bonding, and the same thing as dipolar bonding. So if something like ionic bonding is inside it, remember it's wrong, right? And if ordinary covalent bonding is added without coordinates, you know that is wrong. So just for you to understand how question comes, this is how question comes in your objective. So in CBT, you have to be able to read between the lines. So whenever you're studying, you don't read, what is covalent bonding? No, you have to read dots. There's some things that are hidden that you need to understand. So that is CBT. So that when you go, however the question comes, and the questions will be simple, but the more simple question becomes, the more difficult it is to pass because you might neglect those things that I'm going to ask you. So that's why at the course of the course, I'm going to be pointing something that you need to note whenever you're reading. So this coordinate bond is a special type of covalent bond. But in this particular covalent bond, the shared electrons are contributed by only one atom. Remember, in normal covalent bond, both atoms contribute. But in this coordinate covalent or dative bond or dipolar bond, only one atom is going to contribute to the electron pair that is being shared. And that is why whenever you see this kind of compound, you can see an arrow indicating that this is the person that is contributing. So the one contributing is always donated with arrow. Okay, so because of this particular level, I'm not going to go into detail on this particular coordinate covalent, just for you to understand between normal covalent bonding and coordinate bonding. In coordinate, only one atom is going to donate the electron pair, and that one is being represented by an arrow showing I am the one giving, and the one receiving is going to know, just like the way you talk about that, where the arrow is going is where the arrow is donating to. So the way where the arrow is coming back, the arrow is receiving from. Okay, so oxygen, normally that's why you realize that whenever at the end of the day, oxygen is going to, because it's receiving, is going to be negative. The person that is giving out is going to be positive. So that's what you need to know in coordinate, covalent, or coordinate bond, or dative bond, or dipolar bond. Remember, it has 4 names. So by now, you should know the difference between covalent bond, ionic bond, coordinate bond. You should know the difference between the 3. Now, remember, some of this bonding, the presence of bonding can make a compound either polar or non-polar. When something is polar, it means that it can dissolve in water. It's water soluble. When something is not polar, it behaves like an oil. So your oil is not polar. That's why it cannot mix with water. So when you want to make a polar compound to be mixable, you bring emulsifier. Emulsifier is a binder that mixes oil and water. That's what happens in emulsion, in cream formation, or whenever you want to do your soup. All right. So whenever your oil and water want to mix, there must be an emulsifier to bind them together, so that surface tension will be broken. Okay. Now, what makes a compound polar? A polar covalent bonding means that unequal sharing of electrons, and because there are differences in their electronegativity. Like you're in partnership and one person is having a high share of contribution. Remember, if that person have a high share of contribution, the person is going to also have high share of the output when it comes. So in polar covalent bond, we have atoms that have different in electronegativity, and that's why they cannot, their sharing of electron will be unequal. So the one that have the higher electron will give more and collect more in return. And this is because of their difference in electronegativity, which makes this bond to be very polar. Polar means they are soluble in water and organic solvents. Okay? Then why non-polar covalent bonding are the one that come with equal sharing of electron. That's what you see in oxygen molecule, chlorine molecule. Now, remember, it's talking about covalent bonding that are polar, right? So it means that there are some covalent bonding that are not polar, which means oxygen molecule is a covalent bonding that is not polar because there's equal sharing. Now, but all ionic bonding are polar in nature. Now, if you can remember, we said that there's some covalent bonding, like in methane, they have different or similar or identical electronegativity. It means that their difference in electronegativity is very small, so they can bond by covalent. When there is a very different that is you can notice in electronegativity, like in ionic bonding, they are naturally polar. So ionic compounds are naturally polar in nature. But there are some covalent bonding that are polar because of unequal sharing, because their electronegativity are different, but sparingly different, just unlike in ionic compounds. Ionic compound, there must be difference in electronegativity, like hydrogen and chlorine. So we have compound that can be polar, we can have polar covalent bonding, and we can have ionic compounds. So question can be, which of the following compounds can be polar? If they put oxygen molecule, chlorine molecule, they are not polar, even if they are covalent bonding. Now, in the image, you can see non-polar compounds, covalent bond, which is like hydrogen molecule. The same thing with oxygen molecule. But when there are differences, like carbon and hydrogen and alkane, you can see their polarity. If you want to go, when you start talking about hydrocarbons, you can see their polarity might be very small. And it can also be influenced by whatever any of the atoms that is being attached to them. Okay? Normally, the carbon chain, hydrocarbons are not polar because their electronegativity is not very. But when there are some additives added to them, it can enhance their polarity. So, in essence, polar compounds can be covalent and they can be ionic, when non-polar compounds are all covalent. So not all non-polar compounds are covalent, but not all covalent bonding are nonpolar. Not all covalent compounds are not polar, but all ionic compounds are polar in nature. Okay, let's continue. The next one is metallic bonding. Now, I want to explain this metallic bonding in the way we will understand it. This is a bond, a type of bonding that we can talk about, that this bonding is affected by electrostatic force of attraction. When you talk about metallic bonding, you talk about what happens when your metal that generates electricity, like your heating kettle, there is wire inside that generates electricity, but you can still carry it. But there's something that can happen, and that thing that you can touch without being electrocuted become electrocuted. So metallic bonding can be described as type of bonding where electrostatic force of attraction between the metal ions that are arranged in lattice. Look at the metal ions. These metal ions are these positive ions you're seeing. They are arranged in a lattice structure. Lattice structures means a regular pattern. You can see they are regular pattern. Plus, they are in a regular pattern. And in between them, there is a free flow of electrons around them. This free flow of electrons means their electrons are delocalizable. They are able to move. So the more these electrons move between these lattice of positive ions, they generate currents. And because they are free to move, we call them sea of electrons, because they are free to move. You could just like sea. When a place is sea, this is something that has freedom to move. So that's why they call them sea of electrons, because the electrons are free to move around. So when they are moving around, they are going to generate a strong electrostatic force of attraction. And that is why these metals are regarded to have high melting and high boiling point, because you need enough heat or energy to overcome this force of attraction. Remember, they are not one place. Just like people that are moving, if you have crowd, you cannot control them, because when you're pushing this one, this end, they're coming from another end. So because of that, it's difficult you need enough force, higher force. In that case, you need to deploy plenty armies to overcome the crowd, to keep them at its point. So that's why we need high energy is needed to overcome this attractive force of attraction, which occurs because of movements of these electrons in a lattice metal ion. So because of that, metals are regarded to be good conductors of heat and electricity. Why? Because these electrons are moving, they're generating currents. So when we talk about metallic bonding, we talk about is a kind of bonding where electrons are shared across large volume of metal atoms in ionic cores. What is the ionic cores? And those positive ions are the ionic cores. And the electrons are moving around, generating currents. Because these electrons are always moving around, they are generating current, making this electrostatic force to be higher. So the force of attraction in metallic bonding is higher than that of ionic bonding. Then ionic bonding is higher than that of covalent bonding. And that is why metals have high boiling and melting points. Because of this, the energy you need to overcome that electrostatic force. And because of these electrons are always moving around, generating currents, metals are termed to be good conductors of electricity. So a question can come: what are the characters that makes metals to be good conductors of electricity? Why are metals good conductors of electricity? So many options will come up. But remember, the only thing that made them is because of the free flow of electrons. The more they flow freely around these positive ions, they are generating currents. And the following are responsible for high melting and high boiling points in metals. The reason is high energy that is needed to break this or to overcome the strong electrostatic force of attraction between the positive ions and electrons. So let's continue. So this leads us to the properties of metals. Remember, metals are composed of atoms. They are not made up of ions. Because atoms are made up of proton, electron, and neutrons. So metals are not just ions. They are made up of atoms. So the question is that metal, it can be just like a filling option. Metal is made up of dash. You have option of atoms. You have option of electrons. You have option of neutrons. You have an option of protons. Don't forget. Like I've said, why metals have melting and boiling points. So properties of metal is number one, they have high melting and boiling points. We've said the reason already. Number two, metals are good conductors of electricity. We should have explained why they are good conductors of electricity. The next property of metal is that metals are malleable. That is why if you go to all these panel-beaters, you see the way they will shape metal at the end. Now, metals can be shaped into different shapes without affecting the property of this metal, without changing the nature, without affecting the electrons and the components of these metals. Everything will be in shape because they have the capacity to be changed into different shapes. These metals are ductile because they can be pulled out into wires. And that is some of the cables you see, a product of metals. And that is where those electrons are moving to generate currents. Okay, so properties of metals that are malleable, that are ductile, good conductors of heat and energy, and they are somebody saying something, and they are good conductors of electricity.
The slide.
Metals, I'm going to share the slide after today's class by the grace of God. So you have the slide, okay? I didn't want to share because I want people to be available in class. So if I'm any place I'm able to stop, I'm going to share the slide. I'm not going to give you a slide of the ones who've not done. Some students will be very late. They say, I'll go to YouTube and listen. Please be in class. When you're in class, you can ask questions. If not for the question that people asked yesterday, I would have gone into dative bonding, right? And good enough. It has helped me to add to my question list. So that's why I want you to be in class, and I want you to ask questions, okay? So that you can understand better soon.
Yes,
okay. So we have 4 properties of metal that you must know. They have high melting and boiling points, good conductors of electricity, malleable, and ductile. Okay. Now, let's go to matter. In secondary school, they taught you what is matter. They said this is matter. Those days, you see in primary school, matter is anything that have shape and occupy space. I know you normally sing it. So, human being as you are a matter because you're occupying space and you have weight. Your phone is a matter. So, virtually everything we have in life is matter. As long as the thing can overcome gravity is a matter. Now, in this, we have solid, liquid, and gas. These are different states of matter. Matter can be solid, it can be liquid, and it can be gas. Solid as a matter can stay on its own, but liquid and gas cannot stay on their own. That's why solid has definite shape and volume, because they can stand on their own. Now, liquid need a container to stand, just like gas. But in terms of needing a container, gas need more of enclosed container because it's very volatile. Just like, by the way, of gas, the air you're breathing is a gas. So for you to enclose gas, you need something that cannot allow any sort of opening because it can escape. And that is why liquid does not have any shape. It's only the shape of the container that it has, just like gas too. Now, liquid can have a volume, but gas does not have volume. Because what we only say is that this is the 25 kg. And that 25 kg, they compress the gas to fit that 25 kg. But when you talk about volume of liquid, if I say that this is 10 ml, as soon as you get to 10 ml, I cannot compress it any further. If I want to compress, it's going to explode. That's why at times, if you put water inside your container and it's past the capacity, whenever there's always a measurement you cannot pass because it's supposed to have a space for expansion. So, but if you don't do that and you put something inside a freezer, it's going to explode. That is because it has definite volume. So you have to expand that volume. So the capacity of that container cannot carry it. Now, in terms of density, solid is dense because the weight is visible. While liquid is not as dense as solid. And that is why whenever you want to measure something in volume, and you want to use scale to measure it, you realize that the scale, if it's one liter, if you go to your scale, it's going to give you something like 800 grams or 900 or 950 grams, depending on the weight of the volume of this liquid you're dealing with. Now, because I'm a cosmetic person, I know about glycerin and something like honey. So now when you're talking about honey, you talk about water. You know that honey has more density than water. So if you measure 1 liter of honey and measure 1 liter of water, right? And put them on scale, you can realize that the 1 liter of honey will have more weight than 1 liter of water. That's because of the density. So liquid is not as dense as solid. But if you get something that is solid and they tell you this is 1 gram, go and put it in scale, it will be 1 gram. At times it might even be more, depending on the nature of the accuracy of the scale. But liquid cannot be because they are not as dense as solid. If we come to gas are very, very dense. That's why you have to compress it. The air we are breathing is gas. You cannot hold air. But when you bring something like a balloon and you blow balloon, you're trying to compress that air inside that space. So the space, the shape of that air at that moment becomes a balloon. And because it's not dense, so it can only be compressed inside that balloon. So if you go to the place where they're filling gas, you realize they have to compress, they have to compress it for it to be visible. Remember, it is air. So if it's not compressible, it cannot be visible. You cannot use it to cook. So that's why you cannot compress liquid, cannot compress solid, but you can compress only gas because they are very light. They are less dense. If you want to talk, you raise your hand so I can stop. Okay, ask question. Somebody is raising hand. Oka Oha.
Good morning.
Oka Oha.
Good morning.
Yeah, good morning. Yeah.
I don't understand polar and non-polar bonding. Like when we were teaching, I really did not understand how you explained it.
What's the problem?
I said I don't understand the difference between polar and non-polar.
Okay, non-polar does not have difference in electronegativity. Why polar has difference in electronegativity.
Okay.
Okay, non-polar come from a similar compound. Because there are no difference in electronegativity, so they will be best of the same feather. Why non-polar? They are not the same. Now, the high electronegativity of one atom make one that is less electronegative to bond. Just like when a wealthy man like Ned go and marry somebody that is not wealthy, like you know her, right? She became wealthy. So that is bonding. That's a kind of bonding. So because she's this, okay, when we come to, I think that should be your 213. You know, inductive effect. When a non-polar bond become polar because of the polarity of the neighboring bond, right? So that polarity is by virtue of a high electronegativity. So when two compounds are similar, they are best of the same feather, they will be non-polar. But when one is highly electronegative, the other one is less electronegative, and they're forming bonding, they form polar bonding. So number one thing you must take out is that there must be difference in electronegativity, meaning that the compound must not be similar. So any other question on this polar and non-polar bonding?
No, ma. Thank you, ma.
All right. There was somebody else that was raising hand. Please ask your question so that we'll make sure that we'll tackle each stage before we move to the next.
Please, can you differentiate between ionic bonding and metallic bonding?
There are two differences now. Ionic bonding and polar bonding. There are two atoms, right? One is donating, while the other one is receiving. That's ionic. Metallic bonding is a lattice of positive charges in a sea of electrons. They are far different. This one is plenty electron. This one is just one. I'm donating. Maybe I'm giving you one. You're collecting. We are forming bond. But this one is a sea of electrons, plenty electrons moving around a lattice of positive ions. So they are far different.
Okay,
Who asked the question of ionic and metallic?
I.
Goodness.
No, ma.
Who is I?
Someone else.
Ogechi.
Ma.
Okay. So do you understand? Ionic is a type of bond where one atom is donating while another one is receiving. And because you're donating, just like Ned and what's the name of that our wife? Answer me now. Ogechi.
Ma.
Regina Daniels.
Regina and Ned. So Ned is donating electron. Regina is receiving electron. They are forming bonding, right? But who is donating is Ned. And because of that, they are polar. The bonding is polar. The money is circulating. So polar bonding is when one is contributing and the other one is receiving. Why not? That's ionic. Then in covalent, they are sharing. Then you talk about difference between normal covalent and coordinate covalent is that in terms of coordinate covalent, whatever they are sharing is contributed by one. But in normal covalent bonding, both of them are contributing to share. I have one and you have one, and we need two. So we bring our one to. We bring our. What's happening?
Your voice
Please
is echoing.
mute your mic so that the voice will not be echoing.
Is it my mic?
No, ma.
No, ma, it's not your mic.
Okay. So that's just that. So you talk about covalent and coordinates. They are different. In covalent bonding, both atoms are contributing for the sharing. While in coordinates, one of the atoms are contributing the one they are going to share. So that's one that are sharing, but one is contributing, both is contributing. But in ionic, one is releasing, another one is accepting. Then in metallic bonding, it's just a different kind of bonding entirely. We're not talking about contributing, we're talking about movement of electron in array of positive ions.
Okay, ma, thank you.
All right. Ogun Koya.
Ma, please, between covalent and coordinate covalent, which one is polar and non-polar?
Covalent and coordinate covalent. Coordinate covalent is a different ballgame entirely. Number one, remember, normal covalent bonding are mainly non-polar bonding. You can only talk about coordinate covalent to be polar because if you look at some of the examples we gave, realize that some of them have oxygen. You know, oxygen is electronegative, and anyone that is contributing has high electronegativity because you cannot give what you don't have. So coordinate additive bonding is more polar, while normal covalent bonding cannot be polar because they are the same. Hydrogen molecule cannot be polar. Chlorine molecule cannot be polar. Right? So the kind of covalent bonding that can be polar should be coordinate covalent bonding.
Okay, ma. Thank you, ma.
Question. Thank you. Which other person is asking question? Extra. Okay, you want ask.
So, ma, in when you're talking about properties of liquid, you said like liquid don't have a particular shape; they take the shape of their containers. But when dealing with water molecules, I read that their molecules are V-shaped. Like, I really need clarity on that.
Now, this is water. This is liquid. Liquid is a general form. Water we are talking about having a V shape is a structure of water, not as a matter, as a chemical compound. Just like talking about methane. Methane is a gas. And we say methane we have tetrahedral shape. And now we are talking about that being a gas, it does not have any shape. It's a two different thing entirely. We are discussing them as a matter, as an object, not as their character, as an entity. We cannot talk about honey, just like talking about honey. Honey is a mixture of so many things. Do you understand? So many components. So we are discussing them as a matter, as an entity. If you're talking about a solid having a definite shape, what do we call about do you know the shape of the solid? And we can have different shapes. So we're not talking about their shape as a chemical component. We are talking about their shape as a matter. Liquid does not have shape. So if I ask you, what's the shape of water in Lacasera? What can you define the shape?
All right, ma'am. Understood, ma'am. Thank you, ma'am.
Excuse me, ma'am. I have a question. I have a question.
You won't answer me.
Sorry, ma'am.
The shape of all this water we are talking about depends on their container. That's why you have some are 20 liters, some are like dispenser is 20 liter, different shape. So what determines the shape of liquid is the container. And that's why we have varieties. But we're not talking about the chemical composition or the valence bond repulsion theory to indicate the shape of the molecule, not the shape of the molecule of water. Talking about the shape of liquid, water as a liquid.
All right, ma'am.
Yes, okay. Because when we're going to be talking about when we'll be talking about hybridization, we're going to talk about different shape of different molecules. And these molecular liquid, yes, they have different shapes.
My question is
polar and non-polar covalent substances? Just a few examples.
I've said it already.
Sodium chloride.
Any
polar.
compound that are sharing, they are sharing, they are similar. Something like chlorine molecule, they are non-polar. Hydrogen molecule are non-polar. Anything that are sharing, they are non-polar. They are covalent. Now, if you have dative, if you go to the slide, let me take us back to that slide. What happened to my slide?
Someone decided to use whiteboard or something.
Who has the right to use? Who has the right to use a whiteboard? Who is co-hosting with me?
I have a
And the
question.
person, somebody have removed my sharing. I'm not going to talk to anybody.
No, ma, I was the one. It was a mistake, ma.
Who is the person? What's your name? Because I want to know how you, I want to know how you hacked my system.
My name is Aisha, but I have a question.
No, who hacked my system first?
Oh, okay,
and
sorry.
remove my. What is it? The Aisha?
Yes. No, ma. No, ma.
Who is the person?
I don't know, ma.
The person should own up now before I continue my class.
Ma, I was the one. It was a mistake. I was trying to check the chat, so I mistakenly pressed the whiteboard, ma.
Okay. So your name is Aisha, right? Is
Yes,
Aisha,
ma.
right?
Yes, ma.
Aisha, I want to see you. Let's go resume. I want to see you because I have a query to answer.
No, ma, it was not. It's not hacking, ma. It was a mistake. I wanted to press the chat. I wanted to read the chat.
We are saying the same thing. Now look at if you go to an example of coordinate bonding. You look at sulfur dioxide, right? The kind of bonding that is in. Hello. I'm answering somebody's question about polar, about non-polar. If you look at sulfur dioxide, right, and sulfur trioxide, you realize that sulfur is one donating to oxygen, right? And you can see they have difference in electronegativity, but there is not very much. Because sulfur and oxygen are electronegative, but their difference is very small. And that's why they can form covalent bonding. In that kind of bonding, sulfur is one contributing to oxygen, but they're forming bonding. So this kind of bonding is polar covalent bonding. And if we're having chlorine molecule, oxygen molecule, we have non-polar covalent bonding. So typical example of polar covalent bonding you can use is SO2. Why non-polar only? You can use chlorine, you can use oxygen or any molecule. Any other question on this? So ask, who is the next person asking question?
Ma, please, I want to ask a question.
Chizara.
Yes, ma'am. Ma, I wanted to ask, if there are some noble gases, for instance, xenon, they react with like an electronegative elements like fluorine to give xenon fluoride. Ma, please, why is that so, ma?
Chizara, can you remain on your level now until you get to that level, so that you don't put tension? Other people will feel that they've not read anything. Let's go on we are in introduction. You're going in a even the question is not even for 200 level. So calm down, okay?
Okay, ma'am.
When we get there, we'll talk about it.
Okay, ma'am.
So don't ask people a question that is off this class, so that others will not be tense up. There's some people that are very weak. So when you start asking this question, they feel that they don't know anything.
Okay, ma'am.
Okay, so let's remain here, yeah.
Okay, thank you, ma.
Aisha.
Yes, ma. My own question. Ma, is hydrogen chloride polar or non-polar?
What?
Hydrogen chloride, is it polar or non-polar?
Hydrogen chloride.
Yes,
answer the question. Is there difference in electronegativity? I don't want you to cram chemistry. Is there difference? Hydrogen and chlorine, which one is highly electronegative?
Chlorine. Chlorine.
So are they supposed to be polar or non-polar? Is it supposed to be polar or non-polar?
Polar. Or is it the difference?
Polar,
I know the difference.
Because the difference is high. Okay?
Ma.
Yes, ma'am.
Thank God you understood it now. Please, whenever you look at, you want to talk about a compound being polar or non-polar, number one, if the atoms are different, then look at their electronegativity. If one is highly electronegative, it makes it polar. If the electronegativity are very similar, make it non-polar. It make it polar. If their electronegativity are virtually the same, just like in carbon and hydrogen, in methane, they are non-polar. But if their electronegativity are somehow different, but at least tangible difference, they are very polar, just like SO2. So please understand it. But at your level, we'll not give you question that is the one that are very difficult for you to unravel. Let's have told you that SO2 or a polar compound, they are polar covalent, right? Not ionic compound. There are some compounds that are ionic polar, and there are some compounds that are covalent polar. Okay, so all ionic compounds are polar in nature, all, but not all covalent bonding compounds are polar in nature. Okay. And your Lua, your question.
Ma, please, why is ammonia soluble in polar solvent?
What is different between nitrogen and hydrogen? Are they the same electronegativity? That's why I keep saying, whenever you look at atoms, check their electronegativity and know whether they're solar or not. Nitrogen and hydrogen, in fact, hydrogen is the number one non-polar. So whenever hydrogen is bonding with any compound, the compound is likely to be polar, except bonding with itself. Or carbon. It's the only thing that carbon is virtually like hydrogen. That's why for you to, when you go to hydrocarbon, except you have something like oxygen or other atoms attached to it, that's when the polarities are increasing.
Ma, I have a question.
You are?
Yes, ma. In ionic bond.
Wait. I'll ask because I wanted Temitope to ask Peace because I've given you a chance before. So let Peace ask first. Peace, I ask your question.
Ma'am, you said that that sulfur is donating to oxygen in dative bonding. I don't really understand that part. Like, how is it sharing? How is it donating?
Look at that arrow. If you go to dative bonding talk about that. It's a unique kind of covalent bonding in which one of the atoms are contributing, are the one contributing to the electron they are sharing. Remember, in covalent they are sharing. In normal covalent bonding, both atoms are going to contribute to share. But in dative bonding, one atom is going to contribute for both of them to share. Just like you are hungry and your friend has money. He said, okay, I only have 1,000. Let me buy food so that both of us can eat. What is happening is a type of polar covalent bonding. Why it's only your friend that is bringing what both of you are eating. Okay, but in ionic bonding, your friend said, okay, I'm giving you this. Your friend is buying for you and you're eating it alone. That one is ionic bonding. And in another case is that I have 500 and you have 500. And with the food, for us to buy a reasonable food, it's better for us to combine the money. We combine that 500, it becomes 1,000. We bought food and both of us ate. That is normal covalent bonding. Do you understand it with this analogy?
Yes, ma. I'm
buying food for you. Is ionic bonding. Okay, ask.
No, I said, can you use the same example?
You were saying something.
Yeah, I said that can you use the same example that you used to explain metallic? Like, can it relate to it?
Okay. Metallic bonding can just like an atom. Now it might be something like a sodium atom, right? So we have so much of the sodium atom. They are being arranged, right? Now, remember, in sodium atom, we have one electrons on the outermost shell. Do you understand? So that atom that is on an outermost shell, or maybe chlorine is coming to bond. And chlorine is releasing there's one electron that is coming from chlorine or something. So that electrons are moving across each of these atoms. There's an electron coming from them. So that electron is moving in the midst of this proton. Remember, an atom is made up of proton, electron, and neutron. Neutron is always static. It's only proton and electron. Electron is one that revolves round. So as this electron is moving round in the midst of all the positive protons, that's the metal. As the electron is moving around this metal, they are generating heat. It's the same metal, but there are so many of them. Maybe I have 20 sodium. All of them are arranged. And the electron in this sodium are moving around itself, around the positive ions. So as they're moving, they're going to generate current. And because they're moving around, remember that together. Remember when there's something about strength by mass. So because they are plenty together, they have energy, more energy. And because this electron is moving, so the energy is so much that you cannot just overcome them because it's not one person. It's not one atom. So in that case, okay, let me give another analogy. Now, in a family where there is money, there are four brothers, and all the four brothers are lawyers and doing very well. Now, because of this, anybody that wants to have a case with these people, you have to, I don't know the kind of lawyer you're going to bring for you to overcome them. Because the money they have, in law, they are good. So for you to overcome them, you need higher money. Your money will be much. But you have to go and bring maybe, I don't know, Justice of Nigeria or whatever to overcome the force. So for you to buy into them, you need more money. Unlike a family that has nobody, you don't even need money. Before you enter there, in fact, they will be at your mercy. So because of this positive ions that is arranged in a lattice structure, regular pattern, and there are electrons moving around. So that electron moving around these positive ions are generating currents. Now, this current that is being generated is making them to be good conductors of electricity, because what brought about electricity is when currents are being generated. And remember, if you bring your battery, you realize we have positive center and negative center. That negative center is electron. The positive center is this lattice of ions we are talking about. And for any current to come, there must be positive and negative. That's why you see them in battery. That's current. And even people that are wire, they say, where is the negative charge? There must be something you put there. And if you put wire in negative, in positive, it cannot work. So because of that, this is how currents are being generated. Now, but because of the capacity of these positive lattice ions and the electrons, they are so much that you cannot just overcome them. You need higher energy. And that's why we have high melting and boiling points. Are you able to understand it?
Yes, ma'am.
Yes, ma'am. Thank you,
Okay.
MG2,
Okay.
is it
More questions?
Covalent? Magnesium.
Oh, yeah.
Positive bonding. Well, can you give another example of dative
What
bonding?
you say?
Can you give another example of dative bonding?
Another example of what?
Dative bonding.
That just talk about the bonding already. You guys are wasting my time for the class. Dative bonding, I've told you already about what is dative bonding. When one of them are contributing, I've given a scenario of dative bonding. Where you SO2 is a typical example.
Yeah.
Dative bonding is a relationship where only one. Just now, hello? Ammonia is when ammonia and hello?
Yes, ma'am.
Ammonia and borofluoride forming a bond is a kind of dative bonding, because in that case, ammonia is one donating to the boron to form the bond. I've answered that question. Please let me continue. Sorry. I don't want
Man,
to
noble
think like
gas can form the active bond.
I don't want. Sorry,
Sorry, I just want to.
let me continue my class. You guys are wasting my class time. I don't have lots of time. I have so much to do. Whenever you're in a class, you listen very well so that I can't be explaining one thing over and over again. It does not take us anywhere. Now, I was talking about difference between solid, liquid, and gas. I've talked about their masses. All of them have fixed mass in the sense that, but in terms of mass, it is determined by the container. Why that of solid, liquid, and gas, all their masses are. That's why I say the gas cylinder, they say this is 25 kg. It is fixed, 25 kg. If you talk about water, they will tell you this is 75 liter. Is the weight is fixed already. But what informs of the size of liquid is the container. What informs of the size of the gases is also the container, unlike the solid. Now, in terms of movement, solid particles can vibrate and rotate. They can move. Now, the particles of liquid, their movement is restricted by the container. Why gases can move constant at a very great speed. That's why gas explosion is always very disastrous. Liquid is restricted. If you pour water, it will just be moving small, but just a little gas that happens here, you can hear it in the next 5 minutes in Jaja. And that's how somebody can just pollute here. And before you know, 5 minutes, air has carried it. It has gone beyond that. That's speed at which gas can move. A liquid can pour water here. Even before you go and come, that water is still taking its time to move. The movement of gases or liquid are restricted within a space, while gases can move at a constant, very great speed, and they are random. So you cannot say it must move this way. It can move anyhow because it has to do with air. Though change of states, we have what happens when a solid melts. A solid can melt. When you heat solid, there's a transference of energy. So it's going to cause the solid to vibrate. Then when it vibrates strongly, with time, when these forces are being overcome, it starts melting. Liquid, in liquid, the forces are losing when they are fully broken. Remember, liquid can turn to gas. Liquid is already in a melted form. But when you heat them, they become gas. And they can only become gas when all those forces that are losing are fully broken. And when they are gas, you can only see they are gas by them evaporating. So that's what happens when you're boiling water. When you're boiling water, it evaporates. Evaporation means gases are being taken off. And that is water forming gas. Solid in a state, liquid when heated, and further heated gives us gases. Now, there's a situation where a liquid can move to gas without changing to liquid. Why a solid can move to gas without changing to liquid. We call that method sublimation. Sublimation is a process whereby a gas, a solid, cannot become liquid, just move from solid to gas without passing through the liquid intermediate stage. Example is your iodine solid. Iodine is a solid that does not melt, it vaporizes. So that's why the process is called sublimation. So you must understand what is sublimation. Sublimation is important. As a chemist, you must know it. Anybody that is doing chemistry. So when I heat water, my water, when ice block is brought out, it melts. But when heat is applied, it vaporizes, become gas. So that's the change of water from solid to liquid and to gas. Okay. Now, even without bringing it out, if you allow it, it's going to melt. But if you apply heat, it's going to melt faster before vaporizing. So that's for water. But for something like iodine, as soon as heat comes, it vaporizes. So what you are going to notice is that my iodine has gone. There's no iodine again. You cannot see, except there's something to trap that iodine in air. So sublimation is a method you can use to separate a compound that is contaminated with iodine. Like you have sand contaminated with iodine. You want to let this iodine go. Very simple. Just heat it. Whenever you heat it, that iodine will evaporate. Your sand will remain. So that's why iodine is easier for you to separate from every contaminant. Whenever iodine is a contaminant, you don't have any issue. Just heat. Now, a gas can also skip a gas can skip a stage, can skip liquid stage and move directly to solid. We call it deposition. Sublimation is inversely proportional to deposition. When my gas, just like my vapor, iodine vapor, I trap it on air and it solidifies and becomes iodine. The process is called deposition. So if you know what is deposition, you also know what is sublimation. Any question on this? So let's go. Properties of. Okay, it's not 10 yet. I still have 1 second, 1 minute.
Okay, ma.
Yes. And let me finish my time. So I'm going to stop on these properties of gases. Properties of gases, we have compressibility. Gases can be compressed. When they are compressed by exerting pressure, the volume is reduced. Gases can expand. When pressure is exerted on gas, it can contract. On the other hand, when the pressure is removed, it expands. That's why when your gas cylinder bursts, it expands and it bursts. So when that pressure that is exerted on it is removed, it becomes expanded. And that expansion can cause what causes explosion. Exertion of pressure, solid. When solid pressure is exerted on solid, it can only go downward. You press solid down, press it down. But liquid, you apply pressure downward and by the sides. Because remember, the liquid, whenever it's exerting pressure, is by the walls of the container and down. While gases, you apply pressure all around in all directions, up, down, and center. So whenever you want to press solid, you go down. Liquid is downwards and by the sides, while gases are all directions. So end this class today. We'll see you in the next class, which is on Friday. Thank you.
Thank you, ma. Bye-bye, ma.
I drop your questions. Drop your questions. I send the attendance to my mail as usual. Drop your questions.
Slide for this class.
Sorry?
I said the slide for this class.
Is what?